Hey guys, welcome to science. This is going to be the last unit in life science, and we're going to look at the effects of disease. And what you see right here, it's called the population pyramid. And so on this side is the male population, on the left side. On the right side is the female population, and that's broken down by years. We do 0 to 9, 10 to 19. So if you're in that age bracket, that shows what the population of the United States is. But let's read this short thing about population pyramid. And there'll be some questions we're going to answer. Okay, it says, how can you see an entire population at once? More than 250 million people live in the United States. That's a large number to understand, but statistics can give you an overall view of the population's characteristics. A population pyramid is a graph used to show how an area's population is divided into ages and genders. Each bar in a population pyramid represents percentage of the male or female U.S. population in a specific age range. The shape of the population pyramid gives information about a population too. For example, a pyramid that is wider on top than it is on the bottom means there are more older people than young people. Reasons for this pattern might include a low birth rate, high death rate among young people due to wars or disease, or an increase in the nation's young people moving to other countries. Similarly, a pyramid that is heavier on the bottom means there are more young people than old. So this one, if we look at this, we see in our country, and this is in 2000s, this is a little bit old, that the biggest part is between 30 and 40. So that means at that time, that was the biggest chunk of our population were kind of the 30 and 40-year-olds, because we can see the bar sticks out the furthest in 30 to 39 in the male population, and the same thing in the female population. So that demographic, 30 to 39 in 2000, was the biggest population in the United States. And you can see right above it, it looks like just about 40 to 49 is maybe the next biggest. It's pretty close. Okay. So let's go over these questions. Let's think about the first one says, a decline in population be caused by, so why would a country's population decline? It says a high death rate, low death rate, high birth rate, or low rate of people living in the country. So population will go down. So if people are being born, so C, high birth rate, that's going to cause probably the population to go up. So it's not that one. A low death rate, people aren't dying, so that wouldn't cause our population to go down. So it's either A, high death rate, people are dying, so that might cause our population to go down. And D says low rate of people leaving the country. Well, if no one's leaving the country, it's not going to cause our population to go down. So the best answer there would be A, a high death rate. Okay. So what's generalization number 2 about the U.S. population supported by the graph? So what we're going to have to do here is just look at these individual bar graphs. The first one says there are more females over 80 than males under 9. So let's look at females in their 80s. That'd be right here, 2.18. And let's look at males under 9. It's 7.23. So that's not it. Okay, so we know A isn't right. We just looked at those 2 bar graphs. So, okay. There are more males aged 60 to 69 than females 60 to 69. So let's look 60 to 69. Males is 3.39 and females is 3.8. So that one's not right either because there's more females in that age group. Okay, so let's go down to C. There are more females under 9 than males under 9. Let's go under 9. Females 6.89, male 7.23. So that one's not right. There's more males. So then D, there are more females over 80 than males over 80. So that one is true because we go up here, there are 2.18% females over 80 and only 1.09 males. So we look at this, D is going to be right because in that age bracket, the 80-year-old age bracket, there's more females than males, 2.18 to 1.09. Okay. So that one would be D. This one says a population period for a country with a high birth rate as well as a high death rate would be So that would be high birth rate. So that would be at the bottom because a lot of people are being born. So that 0 to 9 is going to be wide. And then high death rate, basically, it's going to be kind of narrow, basically. So it'd be wide then narrow. So wide then narrow is like a pyramid because if you look at a pyramid is kind of narrow at the top and wide at the bottom. So think about that because a lot of people are being born 0 to 9. So that these bars would be wide. And then if people are dying, high death rate, it's going to get skinnier and skinnier because there's going to be less and less people as you go up because more people are dying. So that would be kind of like a wider at the bottom than at the top. And that's like a pyramid. Okay. Because you think more people are being born. So that these bars and the bottom are going to be wider. Then as they get older, they start dying. So it gets narrow and narrow. So it's going to be wider at the bottom and narrow as you go up. So according to this graph information, the passage, the US population shows, what do you think? Negative population growth, positive population growth, zero population growth, or maximum population growth? So you have to look at basically these bars, and it's not zero because we are basically growing a little bit. Okay. Maximum, I think maximum would be all the bars would be the same. So it's going to be then positive or negative. And which one do we think that is? So just so we're going to see, we're going to go down here and look. And 4 would be B. So 4 is positive population growth. Okay. So that means basically people are basically populating our country. Okay. And according to the passage, why is the shape of the population pyramid significant? So it says the shape of the population pyramid gives information about a population. So this basically gives you information, all the age brackets, as well as male and female population. Okay. So I think the answer, something like that. It says, according to the passage, it's a way to view the characteristics of entire population. Because we can, excuse me, we can look at the entire population of the United States. We can look at males, we can look at females, and we can look at ages. So we can look at anyone from 0 to 80 years plus. That incorporates our whole population. So this is just a good way of looking at the entire population of the United States. Okay, let's go down to, okay, this is environment and health. It says there are many environmental factors that can affect human health, including pollution, carcinogens, bioterrorism. These 3, if not properly controlled, have severe effects on human health. Air pollution can worsen lung disease or cardiovascular issues, and carcinogens cause cancer. Bioterrorism, if not caught, can lead to death in the case of an anthrax scare in 2001. So obviously pollution is, some states it's much worse. Like some of you have probably seen like Los Angeles, because all the cars, it can appear to be smoggy. So sometimes if you live in big cities, sometimes the pollution is a little bit worse, as opposed to if you live out in the country where there aren't a lot of factories, there aren't a lot of people, there's not a lot of cars. Carcinogens, that would be if you live by a big factory or something, and you see those big smokestacks. So whatever like they're making or something, all the waste from their manufacturing like cars or something, some of the byproducts from the metals get in like the water, they get in the air, and those would be carcinogens. And bioterrorism, like those are chemicals that people made that Sometimes I think it was in Tokyo or something. Someone put like anthrax on a subway and it killed a bunch of people. So those are just things to think about. So these are some of the key terms. Air quality index takes in consideration the levels of pollutants in the air and how these pollutants affect human health. Pollution, when chemicals, heat, and noise are added to the environment beyond its capacity to absorb them. And chemicals could be, like I said, that's a byproduct from like a factory or something. Cancer, that's disease that occurs when the cells is no longer regulated and cells divide out of control. Carcinogen, anything that causes cancer, either naturally formed or created by man. A tumor suppressor gene normally works to prevent cells with damaged DNA from dividing. The tumor is a cluster of cells that can be either benign or malignant. In bioterrorism, when diseases are intentionally released or spread. Okay, so the air quality one, you guys, sometimes you might see that on your phone or something. So anytime air quality index is 0 to 50, that's good. That means you can breathe the air without worrying. If you have asthma or something, you have to worry. 51 to 100, it's medium, which is still okay. But anytime you get above 101, if you have like a respiratory issue, it's probably not safe for us to be outside. And you can see 300 to 300, that's 3 alarm fire. You probably shouldn't be outside at all. Okay. And one thing that happened this past year, we had all those forest fires in Oregon, California. And what happens? The smoke from those forest fires, sometimes if you live in a valley or something, it kind of sits in the valley because there's, it's a low point and the air quality gets really bad. Forest fires sometimes can cause the air quality to be really, really bad. Okay. And down here, these are the effects of pollution. And you can see, air pollution, soil contamination, pesticides, water pollution. That happened in Flint probably about 7 or 8 years ago. The water had lead in it, and people were drinking lead, and lead is really toxic to us. It can cause permanent brain damage, especially in young children. You can see down here pesticides. If you live like sometimes by a farm or something, and they're using a fertilizer or something to kill insects so the crops grow, sometimes those pesticides can get in the soil. They get in the water. So that's how soil contamination happens. And all those things can cause like cancer. They can cause like respiratory illness. They can cause nerve damage in the worst case. So all like pollution has some sort of effect on our bodies. Okay. And this talks about cancer. So cancer happens when a genetic mutation of a cell causes it reproduces uncontrollably. Most carcinogens produce mutations in genes that control the cell cycle. For example, mutations in the tumor suppressor gene could cause cells with damaged DNA to get an OS to reproduce, them causing some sort of tumor. So one carcinogen you guys can think of is like when you smoke cigarettes, there's carcinogens in there. That's why a lot of people that smoke, you're more susceptible to lung cancer. Okay, so what happens is your cells basically start dividing, and some of those cells have like the carcinogens from the cigarettes in them, and they can cause you to get like cancer. And it talks about it down here. Tobacco smoke is a really big carcinogen. Chemicals in food sometimes can cause us to get cancer. Radiation, if you live by, sometimes back in the 70s, 60s, and 50s, we had nuclear power plants and people lived by them. Some of the radiation from that caused people to get sick. So a couple things here. It talks about a tumor. So a lot of people, when they get cancer, they get tumors, but not all tumors are necessarily bad. If a tumor is benign, it remains at one part of the body, does not prohibit the body's normal functions. But the bad tumors are malignant. It can grow uncontrollably. It can grow into other tissues. That's when sometimes, you might get cancer in one part of your body and it spreads to another part of your body. Okay. But just remember, you get a tumor, it's not necessarily always bad. It can be benign. But if it's malignant, that's when you have to worry about it. Okay. So then it says when treating cancer, doctors try to remove the tumor without removing the healthy cells in the body. Surgery, chemotherapy, and radiation are all the treatments that attempt to attain this goal. So if you have like cancerous cells that are malignant, the first thing they would go in and try to remove those cells, and then they would maybe try chemotherapy, which tries to kill the bad cells, and also radiation. So they radiate you, and hopefully it kills the bad cells. Those are the options. It says a patient is more likely to beat cancer and survive when the cancer is detected early and the tumor is still small and controllable. Knowing the early signs of cancer, getting routine tests help detect cancer early. Okay. And the last thing we have is this bioterrorism. And that's viruses, bacteria, toxins produced by bacteria can spread through the air, food, or water through contact with the skin. One of the best known incidents of bioterrorism in the United States happened in 2001 when someone set anthrax spores through letters, infecting whoever opened those letters. So, anthrax is a chemical. If you breathe it in, it affects your central nervous system. It kind of shuts it down. You can't breathe, you end up dying. And if you've been watching the news, there was that Russian, I guess there's a political figure that they poisoned him. And that was also kind of a form of bioterrorism. And you can put it in like people's water, drinks, whatever, or in their food. Well, that's basically what it's a man-made chemical that someone purposely puts in the air, food, or water. And that's kind of a form of terrorism. They call it bio because it's biological. It affects your body. Okay. So that's pretty much it for today, you guys. That is the end of life science. We will next week pick up a new topic. And remember, so for life science, I think there were 17 lessons. So I think we'd start 4.1, and it goes to this one, I think 4.17. So I think some of them might be two. So if you want to go back and review life science, just start at 4.1 and go all the way through this one. All right, you guys, I'm going to start social studies here in a little bit. Have a wonderful day, and I will see you guys soon.